applications of quadratics, just like any word problem, you need to have your steps. First thing is defining your variables. So let's read through it first. The length of a rectangle is 5 centimeters more than the width. So that's a relationship between length and width. You're given the area. Algebraically determine the dimensions of the rectangle. This is different from the applications we did in the last unit on quadratic functions, because the last unit we might have something like this, but we had to maximize the area. We weren't given the area. Okay, so if you see the word maximize or minimize, that's where you're looking for the vertex, the maximum point. Okay, and really that's the applications from the last unit. You won't get this in this unit. So it'll really be when we get to the cumulative where you have to distinguish between them. So here we want to determine the dimensions. I want to draw just a little diagram. Okay, so the length of the rectangle is 5 more than the width. So if I let the width be W, then the length will be W plus 5. I don't actually even have to use L in this case. So I'm going to let W be the width. Therefore, the length is W plus 5. Remember, area is length times width. Okay, and we are told what the area is. So 36 equals W times W plus 5. That's your equation. It's quadratic. You've got a W times a W. Okay, so can't solve it right now. Yes, maybe trial and error, you can enter some values and figure it out. But we are algebraically determining, so we're expanding, solving by factoring or quadratic formula. Okay. So we need everything on one side. Oops, I put W5. Normally I put 5 in the front. Okay, so this one you can solve by factoring, it turns out. You're going to get 2 answers. Check. Do they both make sense, or does only one of them? Okay. So solutions are 4 and -9. Okay, so there's 2 solutions to that quadratic. That quadratic is an application for an application question. It's modeling the situation. So when you take a look back, W, it doesn't make sense to have a negative width. Okay, so we eliminate that. We call that inadmissible, as opposed to extraneous, which you may have talked about first semester. Inadmissible just means it's a solution to that equation, but it doesn't make sense for it. Okay, so now we're not done. It says algebraically determine the dimensions of the rectangle. So statement answer. So therefore, the width, let's get it up, is 4 with units, centimeters, and the length is 4 plus 5 is 9 centimeters. Okay. So let statement, equation, solve the equation algebraically, statement answer with units. Okay. So that's a popular type of question, an area question. We'll do another sort of variation on area in a minute or two. Another popular question is comparing numbers, okay? And we did that as well back in max-min problems. We might say, what's the maximum value that gives you, what are two numbers that give you a maximum product? Okay, something like this. Notice how there's no maximum word or minimum word. You're actually given what the sum of the squares is. Okay, so you can find the actual value. So we want to determine the two numbers. It says two consecutive integers. So consecutive means one after the other. And if they're integers, so that could be 4 and 5, it could be 110 and 111, it could be -8 and -7, because they're integers. So we're going to let x be one integer. Therefore, x plus 1 is the next consecutive. See if it says that consecutive integer. Pretty close. Okay. So, what are we doing here in the first statement? We are finding the sum of the squares. So sum means add, and we have to square them. Okay, so that's your quadratic that you have to solve. It's not simplified yet. One side's not 0, so you have to expand and collect like terms. Get everything on one side. Okay, so 2x squared plus 2x, bring the 113 over, so it'll be minus 112. And notice that they're all even numbers, so I would divide everything by 2. And you don't have to deal with such big numbers in terms of factoring. But that's a lot easier to factor. So two numbers that multiply to -56 and add to 1. So, solving that, you get -8 and +7. Now, in this case, it says consecutive integers, so negatives could be okay, right? Though that is not your answer, though. Those are not consecutive integers. The digits are consecutive, but they're not one right after the other. One's negative, one's positive. So you're going to have two pairs. Okay, so there are two pairs of consecutive integers. Get the sketches up here. Okay, so -8, and then if you put it back in your let statement, and -7, 7 and 8. Okay, so go back to your let statement and substitute them back in. So we have our let statement, we have our equation, we show our work, we get our solutions for x in this case, and then our statement answer that summarizes all that you are asked to do. So next one is another area question. It's just a little bit different, but it's a really common type of question to ask. So heads up. A rectangular swimming pool measuring 10 meters by 4 meters is surrounded by a deck of uniform width. The combined area of the deck and pool is 135 meters squared. Determine the width of the deck. So let's draw a picture. They're rectangles, right? So I'm actually going to do this. Okay. Kind of working on its own. And then that just gets some more. Board is not having fun today on its own. Okay, so this is your swimming pool. These are the waves of water. Okay, and it measures 10 meters by 4 meters. Okay, then just like if you go to any swimming pool, can you put your phone away, please? Go to any swimming pool, there's usually sometimes it's a rubberized deck around it. Sometimes it's a tile deck if it's an outdoor. In any case, it's what it means by uniform width. It means it's the same width no matter from the pool, no matter which side you're on. Okay, so I'm just going to freehand this one. So it's not perfect. It's definitely not perfect. Okay. So it's not perfect, but that is going to be the deck around it. And by uniform width, it means, and we don't know what that is, but that distance from the pool to the edge of the deck is the same there as it is there. As it is there. Okay, so on all of the sides, it's the same width. Okay. And so we want to figure what that width is. So that's our let statement. Let x be the width of the deck. So it's not the entire width of the whole thing. It's just that. So draw a diagram and then it's obvious what to see there. You know the pool has dimensions 10 by 4, so you know the area of that. And you know you're given that the combined area is 135. So that whole area, maybe I'll just do it in red here. So this whole thing, right, is 135 meters squared. So really, we want the formula, we want the length of that whole pool and deck and the width of it. So if you take a look, we know from here to here is 10. This part's x and this part is x. So this really has dimensions 10 plus 2x. Here, we know this is 4, and this part's x, and this part's x. So this is going to be 4 plus 2x. So now we have our dimensions of the entire thing. So that's going to be our equation. Okay, so we're given the area of the entire thing, and we know area is length times width. So here we're going to have 10 plus 2x times 4 plus 2x equals 135. Now sometimes, again, you could use trial and error and figure that out, but it does say algebraically determined, and sometimes it's not going to be a nice number. It's going to be a decimal that maybe even irrational. That would be difficult for you to just figure out on the top of your head. Okay? And remember that that x has to be uniform. Makes it even a little bit harder to do it by trial and error. Okay, so expand that out and solve for x. Okay, so big numbers. If you can't figure out factoring, you could always use the quadratic formula, because maybe you can't factor. But if I were to factor this, I would look for two numbers that multiply to 4 times negative 95. So that's 400 minus 20 is negative 380. And I would have to add to 28. So one has to be positive, one has to be negative. When you look at it like that, kind of makes sense. This is 10 off, right? And there's a factor of 10 in there. So if I say 30, oops, I want. If I say 38 and negative 10, I get 28, and I multiply together to get negative 380. So the way I do it is I set up, I don't use decomposition, but you certainly can. I need to get these two numbers from my outside and my inside, right? I can't, with a 4x and an x, I can't get those numbers, okay? So I'm not going to put 4x and x here. I'm going to put the other option, which is 2x and 2x. Now I can get 38 and negative 10. So that's going to be 19. And this is going to be negative 5. Okay, then continue solving. Even though one of them may not make sense, you've got to show it. And then eliminate it from your solution set. So x equals 5 over 2, or negative 19 over 2. This is inadmissible. Okay, so it says algebraically, go read what you have to do to algebraically determine the width of the deck. So that's your x value here. So therefore, You can even put the word uniform, width of the deck is, now it's an application, so when we're talking about width, we probably wouldn't say 5/2. I would probably say 2.5, in this case meters. If it asks for the outside dimensions, then I would put that back in. And you can certainly check. If I put 2.5 back in there, that's going to be 15, and this is going to be 9. So 15 times 9 is 135. You can check it that way. And I think that's the last one in this. You've just got your practice there. So we'll just close out